zero. Okay, zero is mean no need to break the card. This is the traditional one. But in this case, okay, the question is the card closed? In this case, maybe you can define, okay, this is closed. Yes, one. Okay. Need the break? Yes, one. You put the break 100%. Yeah, this is the traditional. If we talk about the fuzzy logic, the same question, yes, the card is closed, but the answer is not 0 and 1, but the answer is can be between 0 to 1. Okay? And you need the break. Okay, it's not 0 and 1, but it has the value between 0 and 1. For example, if the card closed 0.2, not very close. Okay, you can break. Okay, we need a little bit slight break pressure. Okay. This is the example of the fuzzy logic. Okay. Try to return the output or return the answer as the human speaking. Okay. Okay, and this is the name of who think and who create the fuzzy logic. It's very old algorithm. Okay, it starts from 1965. Okay. Okay. By the way, we move to because if we focus on the fuzzy logic, maybe we have to take 1 hour or 2 hours for learning only fuzzy logic. Okay, I try to summarize the concept of the fuzzy for you a little bit, and we're going to move on to the fuzzy C-mean clustering because we are going to do the clustering together. Okay, this one I explained already. Okay, yes, this one is. For example, you have to cluster, okay, and you have 1 point. As I told you, maybe x1 is hit the point that is in the group of Ci. But we have another value we call the membership. Okay, membership in this case we represent with the W. Okay, 90% of 0.9. Okay, is in the cluster Ci, but okay, another 10%, 0.1 is another group, okay, Cj. Okay, but in case of K-mean or DB scan, we don't have the membership value, right? We have only assignment, or we have to assign the point to be the cluster 1 or cluster 2 directly without membership value. But the fuzzy C-mean clustering, it has the advantage that we can know the membership value. Okay, I will briefly talk about the mathematical background of this fuzzy C-mean step. The background of the fuzzy C-mean is similar to the K-mean clustering. You know the K-mean clustering, right? But this one is C-mean. Fuzzy C-mean clustering is similar name. So it has something similar, but it has also something different. Okay. For example, if you have the data set X and you have cluster C1, C2, C3, okay, like you have how many clusters you have, okay? For example, you have 2 clusters C1 and C2. Okay. One is defined by the user and the data is come from your data set. Okay. And the first time you have to random this number. This number is referred to the membership. For example, x1 is mean data point. You have the data point x1, x2, x3 is mean you have 3 data point. In case of x1 to the C1 group, it has a membership value around 0 to 2%, okay, it's 0.02. Okay, but X1 it has the membership value to the group number 2, C2, 0.03. Okay. X1 to group C3 it has the membership value 0.01, but it has the membership value to the C4 around 0.94. Okay. And also this one is represent the membership value between each data point in each group. As you can see, when you random, okay, the first time of the fuzzy CE we have to random because we don't know which is the suitable of the membership value. As similar as the K-mean clustering technique, the first time you have to random the centroid, right? Because you don't know which position of the centroid is suitable. At the same, the first time of the fuzzy CE you have to random it. Okay, but we have the condition for the random number because when you random it, you have to random with the summation of each row. When you sum up, it have to be 1. It's come from the probability, 100%. Okay, so you have to random with the condition as the summation of this one must to be 1. Okay, so if you sum up each row is going to be 1. Okay, this is the first step. Okay, first step you have to random the number of the summation of the one, and then you have to compute the centroid with this equation. It look very x, okay, and over the summation of membership with the parameter p, okay, actually be defined as the 2. Step 3, okay, after you calculate the centroid, step 3 we will update the fuzzy pseudo partition. Okay, if you compare to the K-mean clustering, this step is compared to the K-mean. This step it looks like you try to update the centroid, right? In the K-mean clustering, when you finish the first round, you have to calculate the centroid for the next round, right? By using the average of coordinate point. But the fuzzy C-mean, we have to update the pseudo partition is quite complex. Okay, I will show you later about the example calculation. And then after you updated the value, you have to repeat step 2 and 3 again and again until the centroid doesn't change. Okay, and the same y2, x2, y3, x9 by 4, x10 by 1, and you plot it to the graph. Okay, no need to plot it. I think you understand, right? You have 4 points. You can plot the graph. Okay, and then in this case, okay, we will define cluster C as 2, okay, and P equal to. Okay, so okay, first step. That the first step we have to random the data point, the membership value point, membership values that of each row must to be 1, right? This is the random number because we don't know the good one, but okay, random it. After random, we have to go to step 2, calculate the centroid. Okay, the equation is look complex, but okay, you can start at the below part because it look easy. Okay, I highlight this one. It is the summation of the membership value over with the sorry, power with the p parameter, okay? But the beginning of the example we use p as number 2, okay? And then summation of each column, okay, is come from this part of equation. You can sum up this one, but you have to sum up with the square of each number like this, yeah, because p equal to at the beginning, and then you can get the answer for this row and this row and the weight one, yeah, of this part. Okay, after that, okay, we will consider about the above one. Okay, it is the multiplication between membership value with the point x. Okay, so it's a little bit complex. Okay, I will explain you like. Okay, we focus on C1 first, and then this column first is mean point x, right? This is point x, this is point y. Okay. So right now we focus on the x with the membership value here. Okay. So 1 multiplied with the 0.4. Don't forget this one, okay? Square. And 2 multiplied with here, okay? Don't forget square. Okay, and 9, right? Multiply with this one here. Okay? One by one. And over with the 1.18 is come from the below part you have done before. Okay? So you get the answer, this one. Okay, for the first, and then below one, you just change the x to be y. Okay, this is the y column, and then you do the same thing. Okay, and you get coordinate point of x and y. This is the centroid of group 1. Okay, x and y. Okay, this is the coordinate point x and y. Okay, and then you change it to be the second column of the C2 to find the centroid of group number 2. Okay, and you do like this in the x column, okay, and the same equation you get x coordinate of the centroid, and then you do like this in the second column of y column, you get y coordinate. So this is x and y for the cluster 2. Okay. Okay, right now we get centroid of cluster 1 with this coordinate point and cluster 2 with this coordinate point, okay, from the previous step. After we get the centroid, we go to the third step. The third step, we try to update the membership value. Okay. We try to this is the membership value, but the first time we random. But we're gonna update the membership value with the equation I told you before. Okay, so this is the example. Step 3. This is the data point we have. We have 4 points, x1 and 2, x4, and this is the centroid. Okay, centroid that we calculate from the previous step. In this step, okay, you can do the Euclidean distance, because if you follow the equation in the step 3, in step 3, we need the Euclidean distance, right, in the equation. So that's why we should calculate the Euclidean distance before. Okay. So from this one, okay, it means x1 to c1, x1 to c2. You have 2 points, right? x1 and c1, x1 and c2. You have to measure the distance. So if you measure the distance by using the Euclidean distance, as your homework last week, okay, you can get the answer like this. Okay. After you have the Euclidean distance from each data point to each group, you can go to the equation here. Okay, because this part you already calculate. Okay. But okay, for example, W11. Okay. W11 is mean okay, this is your random number. Okay, I try to represent W11 is this number. Okay, this is W12, this is W21, this is W22, this is W31. Okay, this is W32, this is W41 and 42. Okay, like this. So we try to calculate one by one and update the value inside. Okay, so 1 divided by the distance between x1 to c1. Okay. Okay, so you can put the number you calculate before, like x1 to c1 is 2.54. Okay, is calculate Euclidean distance as the previous step. Represent it here. Okay, and this one is x1 c1 plus distance of the x1 c2 here. Okay, so you represent the equation by the Euclidean distance before. Yeah. You can get the new or the update membership value for the W11 here, and then you change to calculate the next one, the W12. Yeah. Then you have to do like this in every data in the table. Okay, by changing the QI and QK. Okay, 11, 12, 21. Okay. So this is the example when you update the weight. Okay, in the round one. After you finish the previous step, you can get the new or the update weight. Okay. After that, you have to repeat step 2 and 3 again. Okay. It looks like the K-mean clustering that you have to repeat it again and again until the centroid doesn't change. Centroid in this case is might refer to the membership. It doesn't change also, because if the centroid doesn't change, it means that the membership doesn't change. Yeah. If it doesn't change, it's finished. So if you get the final data like this, what happened? It means x1 it has a membership value to the C1 more than the C2. So it means x1 it should be the group C1. Yeah. But in the fuzzy C-mean clustering, we have more information, not only the cluster, but we know that okay, x1 look 88% to be the C1. Okay. And maybe in some cases it look like 50-50, like it's like 0.49 for C1, but 0.51 to C2. It looks like this data is half, So we can get more details, not only the cluster, but we know about the membership values. So this is the example when you try to plot the graph between C-mean clustering and K-mean clustering. When you apply the K-mean, when you plot the graph with the different colors, maybe, green, red, you separate clearly by the color. But in the fuzzy C-mean, you can plot it with the color refer to the membership value. Okay, for example, the red one, this is the red group, but if the point that close to another group, the color might be changed depend on the membership value color. For example, if the membership value color is around 60%, it's going to be yellow. Okay, it means this data is look like half and half. Okay. Because in term of some application like the marketing or the business, if you think about the marketing or business, if you have this graph, you can design some campaign or some promotion to separate this group, because it has some data point or some customer that might change their mind to be this group or this group. If you have some promotion, maybe they can design itself easier. Okay, so this is the example of the fuzzy C-mean clustering. Yeah, do you understand? So I try to show you between K-mean. K-mean it is the basic one. DB scan is good for some data set that have the noise, and also the data is not the circle. Okay, and the fuzzy C-mean, it has the advantage for the data that you want to see the relationship or the membership inside, not only clustering, but you can understand some membership value inside each data point. Okay, so I think these three examples is the good example for you. Okay, but not only three clustering algorithms. We have a lot of algorithms about the clustering, but I cannot teach you every algorithm. Okay, you can study yourself again. If you have questions, you can ask and discuss with me. Okay. So, question? No. Okay, so open the example of the fuzzy C-mean that I sent you already. This one. I put this line for you because I think the fuzzy C-mean it's not the we have to add more the library or the function. So you can run this line first, because this line is going to install the function of the fuzzy C-mean for you. If you run it, it's going to download and install the function for you. Because it's not included in the scikit-learn library. I'm not sure, because maybe the new version of the scikit-learn already have the fuzzy C-mean, but in my case, I use the old version, so that's why I put this one for you. Okay? Let's try to run it. Okay? And if you have a problem, I will help you later. And step one is nothing because just importing the library. Okay, and the main one, it is the fuzzy cmean. Okay, fc means import with the FCM. Okay, this is the main library for the fuzzy cmean classroom techniques. Okay, this one. But you have to run the first line here before going to the next part. Okay, because we need to install. And after you finish installation, you can run this one. Okay. Okay. If you finish install and run the important libraries, you can go ahead to the second part. We try to create the artificial data set. Okay. In this time, we will use the random function again. Okay. np numpy dot random with the normal distribution random. Okay, random with the normal. And you can put the number. Okay. Actually, you don't know about the parameter. Okay, but if you interested, you can copy it and visit the website, okay, about the parameter. But okay, in briefly detail, I try to make the data point that have the 7,000 data point with the two column and 5,000 data point. And my last two, in this case, I try to make the average of the random data with the number -2 for the average of the group data. Okay? And number 2 is like the standard deviation. Okay? And I correct this random data into the A, okay, parameter A. And also I do like this with the parameter B. But parameter B, I try to change the average of the data group with number 2. Okay, it looks like when you plot the graph, you can see two different groups. Okay, one group, the center of the group is -2. Another group, the center is 2, with the different standard deviations. Okay, so right now we have A, we have B. Okay, and then I try to contrast A and B together. Okay? Right now you have A, you have B, but if you want to connect parameter A and B, you can use the numpy.concatenate. Okay, it is the useful function for connect the parameter A or any parameter together. For example, in the example they use the A and B that we random from the previous step here. Okay, we try to connect it together with the concatenate function, and we correct it in the x variable. Okay. Right now A and B connect and keep it in the x variable. Okay. After that, okay, you can do the scatter plot for data visualization. Okay. So you can see we have the two groups of the data. The first group, the average is around -2, right? The x is -2, and another group, the average is around 2. Okay. If you change the value like 3 or 4 or any number, it's going to change the pattern of the graph. It depends on what is your random number parameters. Yeah. So right now we have 10,000 point random with the different style. Okay. Go ahead to the step 3. Okay. We try to fitting or learning with the fuzzy C-mean clustering. Okay. It's very easy. Okay. You just define. Oh, that's 3. Okay. Maybe only 2. Okay, only 2. Sorry, it should be 2. Okay. So if you run this one with n cluster equal to everything finished, but you know the background of calculation as I show you in my slide, it has to calculate the centroid, and then we have to update the membership value with the complex equations and repeat it again, okay? But if you run it fully polarized. Okay. Okay, after that, you know, when you do the fuzzy C-mean, right? The output of the fuzzy C-mean, you can get the membership value. Okay. If you want to know the membership value after learning or after fitting, you can use the variable name dot u. U is come from membership value. Okay. For example, this one, it is the first data. The first data has the membership value around 16% for the group 1 and 83% for the group 2. Okay, the totally, is 1, right? For the first row. And also we have the membership value for 10,000 data points, right? For seeing the membership value in size. Okay, not only membership value, if you want to know the centroid of the final, you can use the dot centers, dot centers with S, okay. Here it is the centroid. As you can see, the centroid, it is the center of the data set, right? If you remember, when you random the number at the beginning of the code, you define the centroid at the average with number 2 and -2, right? 2 and -2, right? This one and this one.
Okay, shit.
It means the centroid of the group, it should be 2 and -2. This one. Yes, it's almost the same with your random number. Yes, a little bit change. And not only the centroid and membership value, we can see the cluster, like the cluster 0 or cluster 1. Right now you have 2 clusters, right? The cluster 1, the cluster 0 or cluster 1, 2 groups. Okay. After finish, you can plot the graph. You see the graph. the same process. When you learn about the K-mean clustering, we have to find how many K is suitable. When you learn about the DB scan, you have to find how much or how many epsilon and minimum point, right? Also, in the fuzzy mean clustering, we have to find how many groups is suitable. Okay, but in the fuzzy mean, we have the solution for finding the suitable of the groups. The first one we call the partition coefficient or PC and partition entropy PE. Okay, we have two solutions to show you in this example. Okay, the PC measure the fuzzy degree of the final cluster, okay, as I explained you in this text. Okay, and you can follow the PC by using these equations. Okay, this equation is mean 1 divided by the how many data you have. Okay, in this case you have the 10,000 data point, right? So it means n is 10,000. Okay, and you have to find the summation, double summation of the membership value square. From this equation, you can write the coding. Okay, because right now you know membership values, right? Just now we show the membership value of the arrays. So you can calculate this one, like the summation of the membership value square. Multiply with this term, okay, and you know we have 10,000 data points. So this is, if you run this one, you can see the membership, the number of data point you have. Okay, you have the 10,000, right? FCM is come from the previous one that you run the fuzzy mean. Okay, dot n underscore samples is gonna return you the how many data points you have. Okay. Because when you change the data set, maybe it's not 10,000, but you can show it and get the output with this function. After that, okay, you can use the numpy.sum fcm.u asterisk, right? This one is double asterisk symbol. It means square, like power with number 2. In Python we use double asterisk. And divided with the how many data you have. Okay.
FCM
ตัวนี้เหรอ ไม่ได้ใช่ไหม
ต้องไป define ต้องไป define หรือเปล่า
FCM มันนะ นี่ FCM มันมาจาก
ในมันเปิดใน collab ไม่ได้
ไม่ได้อาจารย์มันเป็นอะไรนะนี่คือ
เฉพาะ FCM ดอท โอเค okay, if you don't, if you cannot, okay, someone cannot use this one, okay, so I try to change it in. So right now we have the data in
FCM
X, okay, X, right? We correct the data in X. Zero. Yes. Okay. Instead, okay, someone, if you cannot use this function, okay, you can change to use this one, okay, x dot shape index 0 is gonna be same, okay, because right now the data is corrected in the x variable, and I check the shape, right, I check the shape, and I know it, okay, in the index 0 is contain 10,000. And then you change this term to be,
Huh.
you just change. Okay? I think everyone can do it because it is the simple. Okay?
Yeah.
Use only the NumPy library.ได้ไหม So it will return the value is around here. Okay? It's not the same as my case because it depends on your random numbers. It is around 0.8 something. Okay? This is PC. Okay? We have another one that also can measuring the fuzzy degree
Addition.
suitable or not suitable, like how many groups is suitable with the PE, with the below equation. PE is come from partition entropy. Okay, it's measure the fuzzy degree of the final one after. Okay, the PE it is another option. Okay, to find a suitable group or not. The PE equation is similar to the PC, but we have to take log. Okay? Summation of the log logarithm of the membership value multiplied with the membership value here and divided with the minus term of this one. Okay? I think you can write the equation as follow this one. Or this one. Okay, I have two more choice. I have two choice because someone can use this one, someone cannot use. Right? You can select which one is good for you.
ยังไงอะ MP 3 MU H แล้วก็เหมือนกันเลยอ๋อ ใช่12ด้วยใช่P dot log F shape 1 dot P E ทำไมเป็นลบวะ why the X shape have to be a minus ทำไม X shape ต้องเป็นลบนะ
อ๋อตามสมการ
อ๋อ
ด้านบนติดลบนะ มีอันนี้ลบอยู่
ใส่ลบตรงนี้โอเคน
ำพายดอทล็อกแล้วก็คือล็อกการิทึมอันนี้ติดลบเพราะว่า
อ่ะโอเค
Okay. Okay, so any questions? Any problem? I want you to do the homework, the second homework. Okay. Similar to this example, but I want you to make more more two groups. I want you to make 5 different groups of the random data. Okay. Try to make it different, totally different. Okay, we have 5 groups. And then let's try to optimize the cluster from cluster number 2 until cluster number 3, like k equal to t45, but we change to be the fuzzy C clustering with the cluster 2, with the cluster number cluster as 3, 4, 5, okay? And each time that you change from cluster number 2, 3, 4, let's keep the value of PC and PE. Okay. Okay, you have to change the number of cluster, right? This is the number of cluster, okay? 2, 3, 4, until 10, okay? And then let's keep the value of the PC and PE in each time of you change the cluster number. And then let's try to plot it. Okay? For example, you might get the PC like this curve. I don't know, okay? For example, maybe you get the PC like this, and you might get the PE like this in the same graph. Okay? And let's summarize the relation between PC and PE. Because you know when you random the group of data, you random with the 5 different groups. So it means the cluster F5 is good, right? It is the suitable one. So we want to know what happened of the PC and PE when we use the suitable one, the suitable number. Okay, you can see the trade-off graph between PC and PE at the suitable number. Because you know the 5 number is good because you random by yourself. Okay? But we want to know what happened when you plot the graph, and you can summarize the relation between PC and PE in your homework. Okay? So we have 2 homework. Don't forget we have 2 homework. The homework 2, try to study yourself about the silhouette score. It is the solution for tuning the parameter epsilon and minimum point, okay, for the DB scan. Okay. But the data set is up to you. Okay. If someone wants to use the weight and height data set, you can use. Okay. But if someone wants to use the moon data set as the example, okay, you can use it. Up to you. Okay. And the homework number 3, okay, just now we explained already. Okay. Make the 5 group, something like this, okay, with the different, totally different, and plot the PC and PE in the graph, something like this, and we can find the relationship. Submit the homework until before Wednesday, right? Next Wednesday, deadline. Yeah. Because when I assign your homework, I will give you 1 week around before the class, and also I will open the topic submission for you. First come, first serve, okay? For the generative AI presentation, okay? I will post, okay, my assignment, and then you can visit that post and comment below my post. You can comment what is the topic you want, and you have to put your name and your group mate. Okay, maybe what of you in the same team. Okay, put the name and the topic. For example, the topic image generator with or by the what the tools you use, okay? Because I want you to make a different kind of the tools. Okay? I don't want to see everyone the same tools. Okay? Like the ChatGPT, everyone ChatGPT is not good for us. We want to study together with the different tools. Yeah. Any questions?